An important element that we find associated with tornado development in the classic supercell storm, and by classic I'm referring to those in an image like you see here. Your best vantage point in these supercell storms is when they pass across your northern sky, and that means you're to the south of the storm, and when you're to the south of the storm looking off to your north or northwest, you've got a great view of the sky behind it. There's no precipitation, there's no clouds back there, so you've got a bright sky behind it that allows you to quite easily see the wall cloud structure that's present right here. But an important component, if you remember back to that one diagram where you had the downward red arrow, the rear flank downdraft that's taking place within the storm, that rear flank downdraft is actually a drying air. And so as it cuts into the rear end of the storm, it literally eats up the clouds. And when it does so, it develops what we call the clear slot that you can see right in this area right in here. Now this dark cloud line that you see right here is the shelf cloud in the rear part of the storm, and we call it the rear flank downdraft, and it's coming out of the screen towards you. But behind it, the air is drier, and it's literally evaporating clouds as it's pushing out towards you. And the end result is the sky tends to appear brighter behind it. Now right here, this still remains to be the left edge of the wall cloud, and this is the base of the wall cloud, and that's the right side of the wall cloud. So this clear slotting that oftentimes develops this horseshoe type characteristic, and there you can see that actual clear slot edge right there. There's the preferred location for tornado development. And so if you see this process taking place, which might be over the course of a minute or several minutes time frame, but you see the clearing out of the sky, odds are pretty good that that storm is going to become a tornadic storm. In this one here, you can see quite nicely, again, this dark cloud edge that's up at the top here. That's the rear flank downdraft shelf cloud that's wrapping out of the screen towards you. It's outflowing air, and it's dry air behind it, and that's helped to scour up the sky behind it, allowing for basically a hole. Now this over here represents the left edge of the wall cloud, the base of the wall cloud, and the other edge is right over here. And obviously you've got at a minimum a funnel cloud taking place there. At this point in time, your focus really wants to be shifted down to the ground for evidence of upward spiraling debris to suggest it may already be a tornado. So once you start seeing this kind of configuration, you kind of want to go back and forth, up and down, looking at the funnel-shaped cloud, looking down at the ground for evidence of upward spiraling debris that suggests the circulation has made contact and is causing damage. So in each one of these cases, again, you can see that bright line. The dark edge represents the rear flank downdraft cloud edge that's wrapping out towards you, and behind it is where the wall cloud is at and the area in which tornado development will occur. In this video clip that was shot out west of Lebanon by some Purdue students, you've got a funnel cloud that's already beginning to form. You're going to have the clear slot develop as this storm evolves. So notice how right in this area here, how you're starting to dissipate clouds. There's the rear edge of your wall cloud, and of course there's your funnel. Let's now just for a moment shift our focus down to cloud or ground level, looking for when this becomes a tornado. Not there yet, not there yet, not there yet. Looks like it is now, because now you see some debris being lifted. And notice here, as this shelf cloud is pushing out of the screen towards us, you can see the upward rising cloud elements that are taking place as, again, that air rises up over the top of that shelf cloud, but behind it, again, it's kind of scouring out the sky. And this, again, is occurring in the case of the classic supercell, where there's a bright sky behind, which you're able to see a lot of stuff. Not all of our supercells are like that, because in just a moment I'm going to talk about heavy precipitation supercells that don't look so much like this. And they're a little bit harder to be working with because of all the heavy rain. So again, there you can see that rear flank downdraft cloud edge right there. You can see the funnel cloud dancing up and down as a tornado, and in some instances in funnel cloud the rest. But again, an important feature that appears to be associated with tornado development in the classic supercell thunderstorm. Let's watch this video here. On the bottom here, the lowest hanging cloud, that's your rotating wall cloud. Here you can see the clear slot beginning to develop there. So through these time lapses, you can see the upward rising of the cloud elements that's taking place. You see the wall cloud is still quite prevalent. And we're still in time lapse here, so it's still sped up a little bit to help you see upward spiraling rotation in the wall cloud elements, as well as within the funnel, which then becomes a tornado. Now this one here, this is actually in real time. It's a lot harder to discern upward motion and spiraling motion, especially from a video perspective. As you're watching it with your eyeballs, it's a lot harder, or easier I should say, to see what's taking place. Now, also note the size of this wall cloud here. The wall cloud tends to be somewhat cylindrical in shape and perhaps have a tail off to the right side towards the east as it's forming, but generally it's a lot more compact feature as compared to the shelf cloud, which is very elongated. So this is probably a little bit more typical of what you're going to see out there. So that rotation may be hard to view until that storm is getting close to its tornado stage, if it ever even in fact makes it to that point. That one there you can see quite easily the upward motion that was occurring within that wall cloud. So comparison, again, these are the two important cloud features you're watching for. The shelf clouds being elongated, representing downdrafting and outflow, whether it's out ahead of the entire squall line, or the forward flank downdraft shelf cloud at the lead edge of the supercell, and the rear flank downdraft at the rear end of the supercell. They're representing downdrafting and outflowing air, in contrast to the wall cloud, which represents the inflowing and updrafting air. And that's a much more compact cloud feature, and those elements, if it's going to become important, will show upward spiraling motion to you. That you will not see with your shelf clouds. Now, as I made mention, once we get a lot of rainfall in our storms, which is not uncommon here in Indiana, we have what we call the high precipitation supercell. And if you notice the difference between this and the look of the classic supercell, how the hook echo is a lot fatter. This is now kind of kidney bean shaped in appearance instead of comma shaped in appearance. And so in the case of the hook echo, again, much more rainfall, which oftentimes results in a rain-wrapped tornado, making it a very dangerous type of storm to be following after outside. Can anybody see the tornado that's present within this high precipitation supercell? Anyone want to venture a guess?
Mid-center.
Mid-center. Meaning right over here somewhere?
More off toward the right.
Over here?
Yeah.
You're pretty close. Right there is where it was located. But you can see how difficult it can be during a rain-wrapped tornado, which is the case back on September 20, 2002. The tornado that started around Ellettsville and moved all the way through Martinsville and south side and east side of Indianapolis all the way up to Muncie was a rain-wrapped tornado. And throughout its entire life cycle, nobody ever really saw that tornado. All they saw was a lot of rain coming at them. Next thing you know, there's a lot of debris flying everywhere within that rain. A high precipitation supercell. That's what was taking place NCAA Final Four night in Indianapolis back in 2006. This is the forward flank downdraft precipitation area. This green notch here is the inflow notch to the forward side of the hook echo, which is right over here. We were fortunate that this did not produce any tornadoes, but it did produce a lot of strong wind and some pretty large hail. This is the typical look that you're going to find with your high precipitation supercell. Note, you can't see the bright sky behind it because everything behind it is heavy rainfall. Over here to the left-hand side, this cloud as you see right there, that's the rear flank downdraft shelf cloud coming out of the screen towards you. This edge that you see over here on the right side is separating the warm and moist air that's at our back. We're looking westbound down this road here towards this storm that's approaching us. And we've got inflow air flowing into this low pressure center located right there. So again, this is a cloud boundary separating the cool, rain-cooled air to the opposite side from the warm and moist air that's on our side that's feeding that storm. So again, those are your cloud boundaries. The rear flank downdraft shelf cloud acts like a miniature cold front. Over to the right-hand side is kind of like a mini warm front because you've got the warm and moist air that's feeding into that storm, rising upward, and as it's doing so, it's forming the low pressure center at the lowest cloud elements that you see right there.